All right, so today, the last day of the week, we're going to cover two sections today. Section 2.2 and 6.8, two sections. And the first section is going to take us over to page 92, if you need to know that. And this section is on functions and graphs. Functions and graphs. Hey, I know who that is. David, right? Yeah. Uh-oh. Is that Julio?
Nope.
I don't know why I thought that. Let me see. Let me give it another shot, okay? Ariel.
There you go.
Okay. Functions and graphs, page 92. And since there's not that many problems that I need to cover from this section, some of it's specifically 0314 stuff. I think I'm just going to cover all of it. And that way, when you see it again in 0314, it'll just be repetitive, okay? But y'all know that's the way we learn math. You do it a lot of times. So here we go. We're going to start with number 3 as soon as I set my phone to do not disturb. All right, so what we have here for the first example we're going to look at is what we call a relation. A relation shows the relationship between the domain, which are usually the x's, and the range, which are usually the y's, okay? So can y'all see that this shows that there are 5 elements in the domain, and they all map to the same element in the range. So the instructions want us to determine if this relation is a function. Okay? So this is a yes or no question. And the way that you can tell whether it's a function or not is if any element of the domain maps to more than one element in the range. So if -5 was going to 1 and somebody else, then -5 would violate the rule, and this would not be a function. So does any element of the domain map to more than one element in the range? Or does every element in the domain map to only one element in the range? And that's true. And so we would say, yes, this is a function. Do I need to repeat any of that? I do? Okay. So what I'll do is we'll do number 4, and I'll repeat everything I just said, okay? So there is the relationship for number 4. Remember, anything that shows a mapping from the domain to the range, that's going to be a relation.
So this wouldn't be a function because the 6 is going to the -6 anyway.
Exactly. Do you see that we do have an element in the domain that maps to more than one element in the range. And so that means this is not a function, okay? It is a relation, it's just not a function. And I said I was going to repeat everything I said, so let me repeat the important stuff, okay? If every element in the domain maps to only one element in the range, that's a function. But if any element in the domain goes to more than one element in the range, that's not a function, okay? Another way you could think of it, you can say the domain have to be monogamous. You know what a monogamous relationship is? Some people don't know. If you're in a relationship and you only see that one person and you don't like two-time or whatever, you're not. Yeah, basically cheating, yeah. If you're only seeing the one person and you don't have relations with anybody outside of that relationship, that's a monogamous relationship, okay? So the X's have to be monogamous. Notice the Y's don't. Did y'all see back over here that this one Y was with three different X's? So the Y's can play the field, okay? But the X's have to be monogamous for it to be a function. Does that help any? I guess if you think about it that way, about actual relationships, yeah, and you can decide whether the X's are the guys and the Y's are the girls or whatever. You can decide. Yeah. Wow. Do I need to do another one, or is that okay? So can I move on and do something different? I think I will. Let's go to, and I'm going to skip all the way to number 51. I'm going to skip some stuff because 51 and 55 are similar to 3 and 4. All right, so in this problem, what they've given us is a graph. And they want us to know, is this graph the graph of a function or not? Just like the first two problems, we wanted to establish if the relation was a function. Now we want to establish, is the graph a function? And the way you do that is with something called the vertical line test. The pencil method. If you want to call it the pencil method, yeah. As long as you hold your pencil straight up. It's the vertical line test. I like to shorten it to the VLT. The vertical line test. Have y'all heard of the vertical line test? Okay, well, what it says, the vertical line test says if you draw a vertical line and it touches the graph more than one time, it's not a function. So is there anywhere that I could draw a vertical line that would touch the graph more than one time? Or does every vertical line that I could possibly draw touch only once?
I've seen before that there's also a way, I'm not sure what it's called, but it's a function of doing it sideways.
Right.
But that's a different function.
That's a completely different test. So if you turn your pencil sideways, that's called the horizontal line test. And that tests for something completely different. And guess what? We're going to get to that this semester. We will. So this is, yes, it is a function. And the reason is because it passes the vertical line test. So would you like to see one that doesn't pass? Okay. An S would not. We're going to look at number 55. And number 55 is a parabola on its side. So looking at this graph, is there somewhere that I could draw a vertical line that would touch more than one time? Yeah, well, actually, the y-axis would be 1, right? Do you see the y-axis? That's a vertical line that touches more than one time. In fact, there's a lot of places, right? I could draw a vertical line back here. Touch, touch. Or over here. Touch, touch. So how many times is a vertical line allowed to touch? Only once if you want it to function. So this is not a function because it does not pass the vertical line test. And another way that I like to say it, touching's allowed, but only once. Touching's allowed, but only once, okay? And have y'all got a handle on that concept? Right? Vertical line touches more than one time, not a function. What? No. No, we're just going to look at these two scenarios. Yeah. And now I'm going to backtrack and go back to number 19, where we actually get to work with a function. Two x squared minus 3x. And here the instructions would say, evaluate the function. Yeah, do y'all see this right here? F of x, this is function notation. Have y'all seen that before? This does not, it doesn't mean f times x. It means f of x, okay? Basically, it means a function in terms of x. And does anybody know what single letter f of x represents? Y. Did y'all know that? F of x, when you see it, it means y. So we could say y equals this, and it means the same thing, okay? This is just function notation. So what they're doing for part A is they're telling me what number to plug in for x. This says f of 0. So that says, hey, every x needs to be replaced with 0. Every x gets replaced with 0, and then you need to work that out and give me the answer. Yeah, this would be a great time to pull out your calculator if you haven't. Maybe not for this one, but maybe in a minute we'll do one that the calculator would be nice on. What do you got?
0.
It's 0, yeah. Yeah, so this first term is going to be 0, minus that's going to be 0. So the whole thing works out to be 0. In this case, f of 0 is 0. Okay, you want to do another one?
What numbers?
Say it again?
What numbers?
Yeah, okay. So this time we're going to do part B, f of -1. And so now what is this telling me to replace every x with? Okay, so here we go. Now it's going to be -1 squared minus 3 times -1. And do y'all see how I'm putting the number in parentheses? That's important, especially for negative numbers, okay? Negative numbers have to go in parentheses. And this right here can be put into the calculator all at one time and hit equals. If you got your calculator and you see where to hit the parentheses and you know how to get a squared and you know that there's a difference between the negative button and the subtraction key, there is a difference. Two different buttons for negative and minus. You can input all of this at one time and hit equals and get 5. And then some of y'all are thinking, well, I can do that in my head, and that's fine too. Okay? What? Maybe, yeah. Some people may be good at mental math, though, okay? Yeah, I just want to warn you that it's amazing how your brain will malfunction during a test. So it might be nice to practice with the calculator because you might not want to rely on mental math during a test. Use the calculator just to check, just to make sure. Let's do another one, okay? How about f of 4a? F of 4a. So now what am I going to replace every x with? 4a. And are y'all starting to see that whatever's in the parentheses takes the place of every x? Even if it's got a variable, it's going to plug in and replace the x. Got it? And so now we're going to have to simplify this. And now the calculator's not going to help you much because we got a letter in there. So you might need to do it manually. If I'm going to calculate this first term, do I need to multiply 4 times 2 first? Or do I need to do the exponent first? Y'all know the PEMDAS, right? Please excuse my dear Aunt Sally. So what is 4a squared? 16. And the a is going to be squared also. Do y'all see when you square something, it means multiply by itself. So 4 times 4 and a times a. If you're going to square it, you got to multiply by itself. And then the negative 3 times 4, that's negative 12a. And that's going to be 32a squared minus 12a. Mm-hmm. Yeah, so this problem, since we have a variable in here, we're not going to get a single number answer. You're going to get another expression. Any questions so far? Yes, sir.
Why would you subtract this?
Because they don't have the same exponent. That makes them not like terms. Yes, so I'll see people try to subtract those, and it doesn't work because this guy's an a squared and he doesn't have a square. That's a good question. Are y'all ready to do another one? Because I got one more that's going to turn it up. Yeah, okay. So the last example that I want to do, this is the pinnacle of function evaluation, at least in here. Bam!
Every x with a minus 4.
Yes. Now we're going to replace every x with, and did y'all notice that that is a binomial? Y'all know what binomial means? 2 terms. The a is a term and the 4 is a, we're going to plug in a binomial. A minus 4 squared and a minus 4, like that. Look at that problem. I'm getting excited already. I know what's coming. Yeah.
When you square, would subtraction sign turn to positive?
No, because when you square something, it means multiply by itself.
That's why I asked it. Because it would be negative times negative.
Oh, now eventually it will. Okay? But you can't go straight to that. We're gonna have to actually you're like jumping from the top of the stairs down to the bottom and skipping the steps.
But am I right?
Eventually, yes. Yes. Are y'all ready to see how this works out? I'm so excited about this one. So a minus 4 squared. That means a minus 4 times itself. So if I write that down, that's going to be a minus 4 times a minus 4. Notice that's a binomial times a binomial. And to multiply those together, we're going to use a special technique.
No, well, that would be A times A and then A times 4.
Right. But in here, the special technique is the 4-letter F word. What? What'd you say? Oh, I thought you said the actual word. F-L-I-P. That is a 4-letter F word, but not the one we're looking for. Now, anybody know the 4-letter F word we're going to do here? Foil. Have y'all heard the FOIL method? Yeah, we're going to F it up. We're going to foil it. All right, so here's what FOIL says. It says first we're going to multiply A times A. And where does the F come from? Because those are the first ones we do. A times A, those go first. Got it? F for first. A times A to the second, okay? And then we're going to do the A times the -4, and that's the O because those are on the outside. These terms are the outer terms. And that's -4A. And then we're going to do these two guys here. That's the I because those are on the, those are the inner terms. They're on the inside. And again, we get -4A.
Plus 16.
-4 times -4 plus 16.
Combine like terms, that would make it A squared minus 8A plus 16.
Right. Again, do y'all see where the FOIL comes from? First, outside, inside, and then these are the last ones we do. L for last. So do you really need to know what FOIL stands for? I don't know. It'd be nice, but if you understand that it's just the distributive property, that's fine too. All right, and then we don't need to forget about the -3 multiplied by A minus 4. That's going to need to distribute. Y'all don't forget there's another piece back here that's got to keep coming down, and then we distribute the -3. All right, Ariel, right?
Yes.
Yeah, you said the next step is combine like terms.
Yes.
So A squared minus 8A plus 16. And now finally we can distribute that 2 that's out front. And that's going to give me 2A squared minus 16A plus 32 minus 3A plus 12. And if you're wondering when is this ever going to end, this is the last step. It's finally about to finish up.
I do combine like terms.
One more time, yeah.
Where did you get 32?
Where did I get 32?
2 times 16.
16 times 2. 32. All right, so how many A squareds do I have?
1.
What about regular A? And when I combine those two terms, -19 is the coefficient. And the constants, plus 44. And we're finally done. Whew, man, look at all those beautiful steps. You see why I was so excited? Because there's so much work there. That fits right into our class motto. Did y'all even know we have a class motto? Yeah, our class motto is, the more work it is, the more fun we have. And you don't have any say in the class motto. Man, that was fun. Do y'all have any questions about any of that? Yes. I can explain that. These two guys are like terms. So negative 16 and negative 3 is where the negative 19 comes from. Since they're both negative, they're going to add and make a bigger negative. And then the 32 and the 12, those are both constants. They're like terms, and when you add them, you get 44. That's where that came from. Yeah.
Can we do one that has a exponent, or yeah, is it called the exponent on both sides?
Exponent on both sides. Like on both of them?
Yeah.
No. But if you want to make one up and do it, that's fine with me.
No, I'm just saying if we have one.
We're not going to see one like that, no. I know what you're asking, but this will be as mean as I get right here, okay? Like there won't be a squared and then a cubed, like a 3 over here.
No, I was thinking of a 2.
Another 2?
Yeah, like a 2x, 2 minus 3x, 2.
Okay.
We're going to have those.
Ariel. I'm going to learn names, okay? And you may be the first one I learn. So let's do number 19, version B. That means we're going to do something like 19 again that fits your description. And I want you to make it up so that we get exactly what you want, okay?
I mean, we can go with the same one, just version B, 2x.
Okay.
2x.
2x squared.
Minus 3x squared.
Okay. So we're playing the what if game now, okay? Y'all know what that is, right? Well, what if it's this? Did y'all ever do that in high school to get the teacher off track so you didn't have to learn?
No.
Okay, that's something my students used to do to me in high school. They would say, well, what if it's this? Well, what if and I got to the end of the class, I didn't cover what I needed to. I kept chasing rabbits. All right, so if we play the what if game and you say, what if it's that? The first thing I'm going to notice, these two terms are like terms. Did y'all notice that? And I can actually simplify this function. I don't have to work with it like that. I can simplify it. So what will this function simplify to? And if you want to write the 1, you can, but it's not necessary. Do y'all see, since these are both x squareds, I can do 2 minus 3 and get negative 1x squared. I can simplify the function, and then if you had to do something like, can I make a different one this time instead of a minus 4? Okay, so what if you had something like 3a minus 2? What if we now needed to find f of 3a minus 2? Would I need to plug this in for both of these x's, or can I just do it in here? Right, because it'll be the same thing, because these functions are the same.
Well, would the negative bounce inside or outside?
Outside.
That's the answer? The negative 1x?
No,
The negative
this
squared?
is the answer to simplifying the function. Like to make it easier to work with, instead of using this and having to plug in twice and having to FOIL twice, you know what I'm talking about? Here I can plug in, I'll get the same answer, but I only have to FOIL once. I don't know, do y'all believe in that philosophy? The philosophy of least amount of work to get the right answer?
Right.
That's what I live by. Least amount of work to get the right answer. Some people say work smarter, not harder. Yeah, and I believe in that too. Now you said, does the negative go inside or outside? Since that's understood to be like a negative 1 multiplied by the x squared, then that negative is going to have to hang out front. And since that is understood to be negative 1 multiplied, that means that he's going to come after the squared because of the PEMDAS, right? Exponents and then multiplication. So 3a minus 2 squared means 3a minus 2 times itself. And then does that indicate the FOIL method? How do we know when it's FOIL? And how many terms are there? Right. So if it's a binomial times a binomial, if they're both bi, you got to F it up. If they're, but don't tell your mom that you're learning that in school, okay? I learned today if they're both bi, F it up. But if you understand what it means, it's okay. If they're both binomials, you got to FOIL it. Okay, so here we go. First, 3a times 3a. 3a times 3a. 9a squared. Right? You got to multiply the 3's together and you got to multiply the a's together. And then on the outside, what is 3a times negative 2? Yeah, because it's a positive times a negative makes it a negative. And 3 times 2 is 6a. So far, so good? On the inside, I've got another one just like it. Negative 6a. Y'all see how that works? Negative 2 times 3. Negative 6a. And last but not least, negative times a negative makes positive 4. And again, that's the FOIL. First, outer, inner, last. And at this point, would you like to combine like terms first, or would you like to go ahead and distribute that negative? You want to do it now? Okay. So if I distribute the negative now, negative 9a squared plus 6a plus 6a minus 4. Do y'all see if I distribute the negative, all the signs change? And now is that where I stop?
No.
I've got another step? Well, let's CLT. 6a plus 6a. Oh, man, that is fun. That is some fun stuff. I love effing it up. I do. Sometimes I'll get home, after supper and honey, let's F it up.
Yeah, relax.
I'm talking about FOIL. Let's FOIL the leftovers, okay?
Right.
Let's FOIL the leftovers.
Yeah. Let's go with that.
Y'all have any questions so far? I'm having a good time.
We can tell.
Yeah. All right, so let's see. I've got a couple more examples I need to do, and I'm about out of room, so I'm going to add a page. And can I move that up? Click and drag. Nope, I'll do it with my mouse. Drag. There we go. And rename. Him. And a couple more problems, and we'll finish up this section. Number 39. Go ahead. Right here. I did. It is. This guy. You remember the negative out front? Remember from the very beginning that negative out front? Yeah. Eventually, he gets to distribute. And that's how that positive 4 became a negative 4. Because I had to distribute that negative eventually. That's right. And it's hard to see it, but that 9a squared is also negative right here. Negative 9a squared. Did that help any? Thanks for asking. All right, 39. We've got f of x equals. And what single letter does f of x represent? Okay. F of x is 2 minus, and then we've got that. And have y'all seen that before? What does that symbol mean? Which means always positive, yeah. So that's absolute value, which is always positive. And guess what the instructions say? It says graph. Yeah, we're going to get to graph a function. So the first thing we want to do if we're going to graph a function, let's start with a table. And what we're going to do is we're going to pick some x's, then we're going to plug in to find the y's. And once I know x and y, that gives me a point, doesn't it? An ordered pair that I can plot. And if I get a bunch of points plotted, I can connect the dots. Y'all follow me? So in 4 steps, we're going to pick the x, find the y, plot the point, connect the dots. Got it? Boy, that was beautiful. Did y'all write that? Don't worry about writing it down. It's recorded, okay? You can go back and watch it. Pick the x, find the y, plot the point, connect the dot. All right, here we go. Somebody give me a good x number to pick.
-1.
Okay, I'll go with that. Somebody give me another x different. 0. Oh, I see what you've done this before. Okay, now let's not pick too many though.
Okay.
Don't get crazy and pick like 10 of them. Let's do about 3.
I was gonna pick 4.
Yeah, and see what we get. And then once we plot those 3 points, we'll see if we need to add more points, okay? So plug it in for the x. -1 plugs in, but what is the absolute value of -1? 1. But then what is 2 minus 1? And that's going to give me a 1.
That's 0.
0, what is the absolute value of 0? 2 minus 0. 2. Because if you have a number and you don't subtract anything from it, it's the same number. And one more time, absolute value of 1 is still 1. 2 minus 1? 1. And let's plot the points and see what we get. Does everybody know how to plot a point? Do y'all know that the x's are how much you go left or right? And the y's are how much you go up or down. So this first point, it says, hey, let's go over to the left 1 and then up 1. And that'll make a dot. -1, up 1. What about the middle dot?
0, 2.
Yeah, so don't go left or right any. Start at the origin and go up 2. And then the next point, let's go to the right 1 and up 1. So do those 3 points look linear? Can I make a straight line out of those 3? I don't think I can connect all of them with maybe with 2 straight lines I could, like that. Okay, so let's do that. We'll just make 2 straight lines like that. Now listen, I kind of assumed something there. I assumed that just because these 2 points lined up that the rest of them would. It may actually do something like curve. I don't know. Or it may do something like that. I don't know. I just kind of assumed this and this. So what can I do to verify what I've drawn is correct? I can keep going and maybe pick a few more. Let's do that. So besides these 3, what might be another good x to pick?
2.
You got another one?
3. 4.
You want?
Go. Just keep on moving now.
Okay. So 2, 3. Okay.
Because if you go too much, then it's not gonna be enough.
So let's do these 2 and see if they fit the graph. Okay. We're just checking now. Okay. So 2. What is the absolute value of 2? 2 minus 2? And that means if I go over to 2, I should be at 0. Well, that's not on my graph. I think that has to do with me not being able to draw very good, though. And let's do 3. What is the absolute value of 3? 2 minus 3. So if I go over to 3, I should be at -1. And I can see I need to adjust this a little bit. But can y'all see that those points do line up? It is linear. On this side, do you think the pattern's going to repeat over here? Probably so, okay? But I could pick negative numbers like -2, -3, and I could check it. Would y'all like to know a little secret? A little math secret? Absolute value always makes a V. I don't see anybody writing that down. I'll say it this way. V is for value. V is for value. Absolute value makes a V. Every time? Yes. Number 40. All right, same song, second verse. We're going to graph another absolute value.
Oh, but you can start with -2 this time.
I could. You want to start with -2 this time? Hey, let me tell you, the X's, you can pick whatever you want. Okay, y'all understand? You have freedom to choose. Okay, so now can I choose the next one? Okay, I would like to pick 0. I always like to pick 0. And now let's not discriminate. We've got a negative, we've got a neutral, we also need a positive, and let's be symmetric. Y'all know what symmetric means, right? If I have -2, I want +2. If I had -3, +3. Okay, so we'll use symmetry. And now let's plug and play. Let's plug them in and see what we get. Absolute value of -2. But then what is 2 minus 4? Yeah, what about 0 minus 4? And then 2 is going to, again, make 2 minus 4. And do y'all also remember what I said? I said don't go crazy and do 10 of them when you might be able to get away with just 3. Always. All right, let's plot the points. If I go -2, I'm going to be down 2. Back 2, down 2. If I stay at the origin, I'm going to go down 4. And that particular point has a special name. Do y'all know what we call any point that has an x coordinate of 0? Y-intercept. This particular point is the y-intercept. It's where it crosses the y-axis. And then if I go over to the right 2, I'm still going to be down at -2. Can you see the V? I see it. And 41. Is that an absolute value function? What is the shape of the graph? A V, always, right? And since this one's a little bit different because it's got more stuff inside, I think I'm going to let you pick the X's. Anybody want to pick? 3? 0. Oh, somebody learned I like 0. And what? -3. And let's stop with those 3, see what we get, and then we might need a few more. Now, be careful here because the absolute value is like a grouping symbol. It's kind of like parentheses, so it follows the same order of operations. You got to work what's inside first and then make it positive. So 3 minus 1. 3 minus 1. And then make that positive. 2. Y'all follow me? 3 minus 1 is 2. Absolute value of 2 is 2. What about 0 minus 1? And then make it positive. Negative 3 minus 1. And then make it 4. All right, so we've got, man, why did my axis look so crazy that time? Ooh, man, I got to stop doing drugs before I come to class. All right, 1, 2, 3, 1, 2. Over 3, up 2. 0 is 1. 1, 2, 3, 2, 4. 1, 2, 3, and up at 4. There and there. Okay, here's the thing. On the previous 2 graphs, did y'all see when I plotted the points that eventually I got the one that was at the vertex? The point of the V. I'm not sure that this is the point of the V. I'm not sure that this goes like this and like this. Because they're supposed to be symmetric in that the angles are the same here. But if I do this and this, I think that's going to be a bigger opening than that. So let's pick a few more and see if we can find the vertex. Say it again.
I said just go 1, negative 4 and 4.
What do you mean by negative 4 and 4? Oh, okay. I see what you're saying. When I heard you say go up 1, I was hoping you meant let's just use 1 and see what that does. Okay, so let's just pick another number and plug it in and see if it looks like the vertex. Because y'all were going with 2 more points. Let's just add them one at a time until we think we find the vertex. All right, here we go. What is 1 minus 1? And the absolute value of 0. And so that'll be the x-intercept. Do y'all see when the y is 0, that is the x-intercept. And now if I connect this dot here and here, is that going to look like a symmetric V? Yeah. And just to prove that that is the vertex, let's also look at positive 2. So 2 minus 1, and the absolute value of 1. And do you see now it's headed back up? So do you see these points are coming down? This looks like the lowest, and then they start to head back up. So when you're graphing an absolute value function, you do want to make sure that you find the vertex for sure, and then you can make the V. Any questions on graphing absolute value functions? Anybody? Okay, what I would like to do at this point before I move on to the next section is I would like to introduce everybody to Desmos. Have y'all heard of Desmos? Okay, it is spelled D-E-S-M-O-S. Desmos. It's a website. That's an online graphing calculator. This is completely free to use, and it is also an app you can download to your phone. I have the Desmos app on my phone just in case I want to graph something at Walmart, okay? Yeah, so what we can do with Desmos, once we log in, over here, this is where I can input an equation, and Desmos is going to graph it for me. So what was the last equation? G of x equals x minus 1. So in Desmos, I can say G of x, just using the keyboard, typing that in with the keyboard, equals, and then if you pull up, let's see, hide that. Why is this here? Hide. Oh, there we go. Something was in the way. Do y'all see this little symbol down here? This, if I click that, I've got access to the toolbar. And right here, absolute value. So what was it? X minus 1? Enter. And I can immediately see that this graph on Desmos is exactly the same as what I drew. Desmos. Y'all see what I'm saying? Now, the nice thing about this versus like a TI 83 or an 84, number one, it's free. And number two, the ability to use it is a lot easier because I don't know if y'all ever used one, but to zoom in or out, you had to change your window settings or whatever. On Desmos, all you got to do is scroll with your scroll wheel. And you can zoom in, zoom out. You can click and drag to relocate it, to move it around. Oh, no. But if you're needing to verify your work doing your My Math Lab, you can have a Desmos window open and a My Math Lab window open, and you can check, what you're doing here. It's a great utility. And you can, instead of f of x, you can just say y equals absolute value of, let's say, x minus 1. And it does it instantly. And another cool thing is you can actually click on the graph, and it'll instantly give you the y-intercept and the x-intercept. So later there might be questions that say list the x-intercept, list the y-intercept, and if you graph it in Desmos, you just click on the x and y-intercepts, it gives it to you.
We're trying to put the absolute value on just x, the minus 1?
Right.
Okay, because...
Right, so these are different functions.
Yeah.
Yeah, so do y'all see the difference between the two? If the number is inside the absolute value, that's going to take the v and shift it to the right. But if the number is outside the absolute value, that's going to shift it down, which is kind of nice to know. Numbers that are inside do a left and a right shift. Numbers that are outside do an up or a down shift. And you can play with this if you want to just experiment. It's real easy to just play with an experiment. Okay, I just wanted to show you that there is a tool available that can help you with this. Desmos is a great tool. Any questions before I move on to 6.8? Anybody? Did y'all make a note of Desmos? And did you also note that you can download the app? It's completely free to use the app on your phone.
I already did.
I don't know. I know that you want to log on to the Lone Star instead of the Visitor. No, don't do the Visitor. Do the Lone Star with your Lone Star login.
I'm using it right now.
Are you? Cool. Yeah, it's nice. All right, so what are we going to next?
You tell me.
We're going to 6.8, I believe. And that's going to take us all the way over to page 426. So we're going to go to page 426, and we're going to look at piecewise functions. Piecewise. Have y'all heard of a piecewise function? Okay, good. That means that I probably need to start with a basic one. So we'll start with number 30. And that is a piecewise function. So I've got f of x. Remember, f of x means y, right? And the values that I get for y are going to depend on the values that I use for x. If I use any x that is less than or equal to negative 2, then this is going to be my y coordinate. But if I use any x that's greater than 2, this bottom piece is going to give me my y coordinate. So it's a piecewise function because, well, there's two pieces and you have to be pretty wise to know which one to use. That's why they call it a piecewise. That's kind of a joke too. Nobody laughed. All right. So let's see if you can find a value of this function. Let's start with f of 0. We're going to try to evaluate a piecewise function. And do y'all see that the number in the parentheses, that is an x value? That's my x. So is 0 less than or equal to negative 2? Or is 0, why did I put positive 2? I'm so sorry. That should be negative. We were going to have a number that didn't fit either one. Is 0 greater than negative 2? That's true, right? And so that means that this x is going to plug into this piece, and I'm going to need to work that out.
Oh, wait, so before you get into one, so you got to figure out that number that you gave us on the 0%, this time 0. We have to figure out the right side, and then depending on which one it fits, we got to go to the
Right.
Oh.
Right. So if I could, I'll add a couple of things here. And I haven't used color at all this semester, so we're going to use some color today, okay? Bam. And so what I like to do, I like to call that. Oh, how did I know to use this one? Okay, here's why, and I'm glad I just wrote that down, because this back here, I call this the test zone. So for every number for x, you have to test it to see where to put it. So you're going to say, is 0 less than or equal to negative 2? Is that true? No, 0 is not less than or equal to negative 2, right? That's not true. Is 0 greater than negative 2? So if this is true, that's what you do. And I made it rhyme. If this piece is true, that's what you do. Got it? And got it? And like the movie Highlander, there can be only one answer. Only one of these pieces will be true. Let's do another one. How about f of 1? Again, because 1 is greater than negative 2. And let's see, that's going to be a half plus 6, which is 6.5, which I think is, let's just call it 6.5. A half plus 6, 6.5.
Wait, so now why don't we do 3 or negative 3?
Okay, so now you're playing the what if game again. So what if it's negative 3? Playing the what if game. What if the number is negative 3? Yeah, because is negative 3 less than or equal to negative 2? So if that's true, that's what you do. But is there an x to plug into? Okay, well then the answer is 3.
Oh, boy. Okay. I expect it to be that easy.
Do y'all see if x is negative 3, then this piece is true, but there's no x to plug the negative 3 into, so the y is 3. Did y'all see that? Y is 3 for any number less than or equal to negative 2. Let's do another one. How about negative 2? What if I do f of negative 2? Now it's the first one again, right? Because negative 2 is less than or equal to negative 2. It's equal. And so that answer is 3.
You have one that has an X on the top of it in the book.
Oh, yeah. Yeah. In fact, the one we're going to do next has 3 pieces. Not just 2, 3 pieces. Does anybody want to play the what if game one more time for this one?
I mean, you can only, it's either positive or above negative 2 or below negative 2.
Right. See, now you're learning. It's either going to be this or this, right? Depending on whether it's above negative 2 or below negative 2. Yeah. So do y'all see how to evaluate this? Okay, so listen, before I crank it up a notch, and this class does end at 2:50, right? So I got some time left, and some of y'all are not happy about that, but I do have some time left. I'm going to play the what if game myself, and let's say what if, instead of evaluate, what if it said graph? What if I had to graph that? Let's look at what if it said to graph, okay? Well, did you notice that I've already done 4 x's?
That's what I'm saying.
Yeah. So I've already done 4 x's and I got 4 y's. Did y'all notice what I'm doing is generating ordered pairs? X, comma, y. Did y'all see that? I'm generating ordered pairs. So I can plot some points now. 0 is 6. I know that's a point. 1 is 6.5. 1, 2, 3. Negative 3 is 3. Negative 2 is 3. You with me? So all I did is I took the points that I've already generated and I put them on the graph. And then what I'm going to do over here is I'm going to write down the table that shows those points. And I'm going to start and go from smallest to biggest. Negative 3, negative 2, negative 2, negative 1, 0, 1, maybe a 2, like that.
Why'd you put negative 2?
Did you notice that? I'll explain that in a second. Everybody got that written down? Keep writing. Hurry the hell up.
Give me a second.
That's a joke. That's a joke. Okay, now let me explain, because you noticed that I wrote negative 2 twice, right? I want you to look at my function and notice that negative 2 is what we call the transition point. When we reach negative 2, we're going to transition from this piece of the function to this piece of the function. Do y'all see that? Anything up to and including negative 2 goes here. But what happens as soon as I get bigger than negative 2? It transitions, right? So whatever the transition point is, you have to use it twice. And then I'm going to label these points top and bottom. So these two X's, they belong in the top piece, right? Because those two numbers are less than or equal to -2. Those go in the top. And do all of the other ones fit in the bottom? Well, except -2. It's not actually true there. But are all of these other numbers greater than -2? Okay. So what did we get for -3? We got 3. -2 was 3. We didn't actually do -1, did we?
We did positive.
We did +1. Well, we need to do -2 in the bottom also because I said so. So let's plug -2 into the bottom piece and let's see what we get. Okay? So f of -2, this is top, this is bottom. 1/2 -2 plus 6. So if I plug -2 into the bottom piece, what is -2 times 1/2?
I didn't see you put the negative. That's fine.
What is 1/2 of 2? So that's going to be -1 plus 6. That's going to be 5.
I didn't see you put the negative. That's why I won't put it.
So that's a 5. And then -1 is going to be 5.5. 0 is going to be 6 because we already did it. 0 is 6. 6.5. Do you see a pattern?
And then 7.
Yes.
I'm confused. Why? So the first -2, plug it in with the 3, right?
Right.
No? Okay, so why do we plug the second -2 in with the other?
The reason we did that is because -2 is the transition point, and whatever the transition point is, you have to plug it into both of them. Did y'all get that? So if you're going, why did I put it in the bottom when it didn't really belong there? It's because it is the transition point, and I have to look at what happens as I get really close to it. Now understand that since -2 doesn't really belong in the bottom, it's not really a point on the graph. So what we're going to do is we're going to label that open, and this guy is solid.
Okay, it's always gonna be like that?
Always. Because -2 is not really greater than -2. That's not true. But I have to plug it in to see what it gets close to. And that's going to be an open circle because it doesn't really belong there. But -2 does really belong in the top, so that's a solid dot. Yeah.
Would we still graph it though? The -2 side?
Yeah, we're going to graph it. But when we plot it, it's going to be an open circle, not a solid dot. Any other questions before I plot my points? Okay, here we go. We've got -3, -2 is at 3, but -2 is also at 5, or 5, and that's an open circle. And then these go like this, and these go like this. Got it?
Oh.
Yes or no? Got it?
Oh, would that still be a function, right? Because it's open. That's why I was going to, because that's that open circle and the closed circle. They would.
You were worried about the vertical line test, right? You said you were wondering if it would be a function, right? And since this is an open circle, if I draw a vertical line, it'll pass through and not touch, and only touch here.
Yeah, because it's open.
Yeah, so it is actually a function because it passes the vertical line test because that's an open circle and a solid dot. Hey, wouldn't it be nice if I could plug this into Desmos and check?
I mean,
I can. I'm going to teach you. I'm sorry, I didn't mean to holler. I'm getting excited. So let's go back to Desmos. And let's say we've got f of x equals, now what was the top piece? 3, right?
yeah.
But did you notice that this function, this back here, we're going to call that the restriction, because this top piece is restricted to only these values of x. And if I'm going to do that in Desmos, the way I do a restriction is I'm going to click the ABC button, and do y'all see these guys right here at the bottom? Can y'all see those at the bottom? Ah, braces. Aren't you glad I taught you that word? Because we see it a lot. So we're going to click braces, and we're going to say x is less than or equal to -2.
How would you put in the bottom part?
And if I scroll in a little bit to where there we go. 3. Now, do y'all see that that's doing exactly what my graph did, starting at -2? It's just a horizontal line. Okay, I'm sorry, Ariel, what was your question?
Oh, how would you put in the bottom?
Okay, so we're going to do on another line, we're going to do f of x and then put in the other one. So 1/2 x, what was it?
1/2 x plus 6.
Plus 6, but then it had a restriction, right?
X.
So we're going to grab the braces and we're going to say x is greater than -2. And if I scroll out just a little bit, do y'all see that that looks like what I drew? That's what I drew. That's what it shows. Y'all see that? Now, do you see you can't really see the open circle and the solid dot? But I can show it to you. If you click on this line, you can actually drag and see all the ordered pairs. Look at that. There's one. 4, 8 is an ordered pair. Watch this. If I go all the way back, oh, what does it turn into? Yeah, but do you see it's open? It shows me it should be open there. And if I click on this other graph and I drag all the way to the end, what does it show? Solid. That's a solid dot. That's the open circle. This is cool stuff. Y'all, I don't think y'all fully appreciate what I'm showing you here. This is cool stuff.
I'll bet you they will in like 4 years.
Man, all right, let's do another problem. Let's do number 31. Man, number 30, and what? It's 50. Okay, I got 5 minutes. H of x x is less than -5. And x is greater than or equal to 1. Bam! Look at that function. How many pieces are there?
3.
1, 2, 3.
But that's the minimum was saying it has to be greater than or equal to -5, but not greater than 1.
Right. Less than 1. In other words, all of the numbers between -5 and 1, all of those numbers fit in the middle piece, including -5, but not including 1. Where is 1 included?
The
Bottom piece. How many transition points are there? How many transition points? 2. See the -5 and the 1. Those are my 2 transition points.
That's just including the top and the bottom.
Right, so if I'm going to graph this, can somebody pick an X that is definitely in the top piece? -1 is not in the top.
Oh, the top.
-6 would be, because it's -6 less than -5. And do y'all see the top piece has to be numbers that are less than -5. So -6 is definitely less than -5. What else could I have picked? -7, -8, negative. Do you see what I'm saying? Any X less than -5 goes in the top. And is -5 a transition point? So -5 is going to have to be used in the top piece. That also means that -5 is also going to have to be used in the middle piece. Do y'all see why? Because -5 is included there. -5 is greater than or equal to -5. That's true. What is another number that could go in the middle piece? -4. What else? 0. Could 0 go? Okay, remember I really like 0, so I'm going to put him. And then, what is the next transition point? 1. Do y'all see that? 1 is a transition point. So I'm going to have to use 1 twice. I'm going to have to use 1 in the middle, and I'm going to have to use 1 in the bottom. Pick me another X that goes in the bottom. 2. What else could I have picked in the bottom? 3, 4, 5. Any number bigger than you see what I'm saying? I don't know what I'm saying. Do y'all see how we're picking these numbers? And do you see that I'm picking at least 2 for each piece of the function? And the transition points have to be used twice. All right, so this is the bottom. And now let's calculate the y values. Plug in the first 2 numbers into the top. I'm going to need some calculator assistance. -6 times -3. Positive? And then 18 minus 18. And so that'll be 0. Do y'all see how I get that? What about -5 times -3? 15? 15 minus 18. And I'm going to label that open. Why would I label that open? Does -5 really belong here? Because -5 is not less than -5. -5, this is not an actual point on the graph because it doesn't belong there. So it's going to be an open circle. Next, -5 in the middle piece. 1, 1, 1. Right? Do y'all see the middle piece is easy? Anything in the middle is 1. And I'm going to label this bottom one open. Because does 1 really belong there? No, 1 doesn't really belong. 1 really belongs in the bottom piece. And that's 3. And 4. And then I can plot those points and I can play connect the dots. Making sure that the open are open circles and all the other ones are solid dots. And then these 2 points I can connect. These 3 will all connect. And then these 2 will connect. And did I show y'all how to put these into Desmos? And then here's your restrictions that are going to go in the braces, okay? And I'm sorry, I'm out of time. So we're going to have to kill that right there.